In the next example, if you notice, it is a cubic root problem, so you don't have to worry about extraneous solutions. I always think it's a good idea to check your answer anyway, but if you plug your answer back in and it doesn't work, then that's your cue that you made a mistake. So obviously I want to add 1 to both sides. That's not a part of the root. And then to undo the cubed root, I'm going to cube both sides. And that leaves me with just the radicand of 2x minus 9 and 27, and then I can solve it like a normal algebra problem. So I got 18. That is the only solution. And again, it's not a bad idea to check. Just make sure you did your math right, but it should work, and it does. Same thing with example 3. It's a cubed root, so you don't have to worry about extraneous solutions, but always a good idea to check it. So I'm going to add 9 to both sides. I get 3. And then I'm going to do the opposite of cubed root, and I'm going to cube both sides, and I get 27. And again, if you want to check it, you go for it. You are going to get -6. So what I'm going to do is I'm going to do the next type of levels, a little bit more work that goes into this, and then I'll put a new video that takes you through the next problem, which is a lot of work. So looks like I already have my root already isolated. That's great. So the next step would be to square both sides. Now here's where you got to be careful. You don't want to write squared, squared, squared. Okay, that's not going to work. What you need to do is you need to put x plus 1 in parentheses and then raise that to the second power. So that's going to require foiling. So if you FOIL this out, you're going to get x squared plus 2x plus 1. And the square root over here and the square are going to cancel each other out. And then you have some choices. You can either try to use factoring or quadratic formula, complete the square, your choice. This is convenient because this problem factor is nice and pretty for us. So that's how I'm going to solve it. So it looks like I'm going to get +7 and -2 as my answers. Now, here's where you got to be careful. I had to square both sides at some point, which means one of these solutions could be extraneous. They could just be a false solution. So we need to check both of them. I'm going to check 7 first. I literally put 7 back in for x into the original problem, and let's see if this is a true statement. 7 plus 1 is 8. 49 plus 15 is 64, and the square root of 64 is 8. So that one works. Now I'm going to check -2. -2 plus 1 is -1. And the square root of 1 is just 1. It's not -1 because I didn't put plus or minus out here. Remember, if I draw the root, you do not write the plus or minus. So -2 does not work. So therefore, we reject that solution. This problem has one x-intercept, and that's at 7.